Hi, Kat here for Lightwave Digital. In this video, we're going to be talking about the fluid mesh reduction and remesh fluid as options in Lightwave Flow. If you've just been catching up with this, Lightwave Flow is a new fluid dynamics plugin that has been shipped with Lightwave 2024, and it is based off of the Newtonian physics libraries. It's only available for the PC as it makes use of CUDA, and the libraries are only built for NVIDIA graphics cards using the CUDA library technology. So that said, let's take a look at what we've got here. I have a setup that we used in a previous scene and video on this tool, and we've got something that, in preview mode. Let's take a look at it, just run it. We've got a glass that, kind of falls into this bin of water. Got a couple of spheres that are in there, and kind of an emitter or a tap or something like that. And we got some water going over the edges, droplets or what have you. Now, that's largely because the geometry for this tub isn't detailed enough for it to kind of hold water. You actually need a little bit more geometry on the inside to prevent particles from infinitely being able to pass through in the hard corners. But for now, this will just be great for demonstration purposes. So let's hit pause on this and make sure that we've got an output folder that we're baking to. And I'm actually going to open up this folder, and we're going to bounce back and forth to it on a regular basis during this demonstration, because I want to show you the size difference in these objects. All right, one other thing before we get started, we're going to make sure that we've got a surface for this on our surface handler. Okay, so we want smoothing for sure. We want maybe some roughness, some specularity. Let's go 5% roughness. We want some translucency, 100%, and we want some transparency, 95%. And we'll put this up to some near water, which is 2.33 for refractive index. Give this a little bit of a bluish tint, nothing crazy. Okay, right, and save all objects. Okay, it's important for when we're baking away. All right, so now that we've got this, we'll take a look at the file sizes with the bake in this folder. So I'm going to just hit Control A, delete those, and we'll watch them generate in real time here. So we can hit run, and well, I'm still in preview mode. So reset, bake, hit run. Now we'll watch it go. So continue. Meshes are coming out at about 900K, give or take. They're writing themselves out. And of course, because there's more geometry over the course of time, they're going to get larger, but not bad. We're just interested in a file comparison of these first generated meshes in the sequence so that we can get an idea of what these mesh reduction options are doing for file size and also the quality of the mesh. Okay, so we've got enough files here. Let's take a look at what this looks like with VPR. The reason being, we want to see what the fluid looks like after it's generated to see if it's nice and high quality and we don't have any artifacts of strangeness going on. We got some nice looking Colgate liquid gel or something. I don't know what that is. Let's go to camera mode here and make sure I've got some additional adaptive sampling for anti-aliasing just to clean it up so we can make sure that we don't have any artifacts in the mesh. So it looks pretty good. Okay. Maybe triangles or visible quads that we can see. So not bad. But these are anywhere from just under a meg to over a meg by the time it gets going. And then obviously, depending on what your conditions are for your simulation, these could grow from, just a couple hundred K to several gigs in size, which would be quite scary. So these file reduction via the mesh reduction tools are kind of important to understand. So let's hit reset and go back to wireframe mode and just step through and see how dense this mesh is right now. Pretty dense, visually on screen, even though it's really not a lot of data at all. If we take a look at these objects, you can see that each one is roughly 30, 40, 50, 56K polys, keeps going around 52, 54, 55. Not bad at all, really. And then things start to reduce a little bit, and it's probably going to start cranking up. Of course, I didn't simulate all the way through here. So let's take a look at what a reduction using the same equation, which was actually not activated unless you are above 0% in the file fluid reduction or fluid mesh reduction. So now this is going to do dominant quads as the reduction method. Okay, so we're going to go to our folder, kind of remembering where we were with 842K off the bat. So we'll delete all this. Boom, boom. And let's hit run. Overwrite in the files or delete. There are options there. Okay. So now we're at 300K, 315, 315. Slower performance in terms of the generation and the reduction of the mesh, obviously, because we're doing some additional math here. But let's take a look also at the performance of Lightwave in the background. Now, we have some hyperthreading going on here, or multi-threading if you want to call it that. But because of the way that multi-threading works, it's kind of like an accumulative process. So we get up to say 30, 40, 50%, and then by the time that's the operation is done. So if you're concerned about it not being all processor consuming, understand that these operations that Lightwave's doing in the background to reduce this file while we're working with the GPU for the generation of the file is a completely different animal. So we're working in balance. So we've got 24 to 50%, and then we got 10 to 30% on the GPU. And because of what it's doing, the operation is basically over there before it can spin up to full speed, full power. So don't worry about it not using all of your GPU or CPU. Later, when you're working with extremely intense meshes and the GPU is being tasked with a lot of physics operations, yeah, you'll start to see that number increase. But for this demonstration scene, it's not really a too strenuous thing, so it's going to do what it's going to do. And keep in mind also that we're writing these files up to disk, fastest disk possible, M.2. In the very least, use an SSD. And last but not least, as the last resort, spinning if you have to work with extremely large files. Another reason why you'd want to use these file reduction or fluid mesh reduction properties is to get away from the load that might happen over the network if you're rendering this in a network environment. If you can work with 50% mesh reduction or maybe 25% mesh reduction, and it's going to reduce the amount of 150 machines on your render network to load this stuff up and render it, yeah, you definitely want to make that mesh reduction operation part of your production workflow. And don't forget, if you're working with Octane, it's also going to be a consideration because you may have to do a full scene reload in some cases. So that's going to take some time to get it into the GPU, less amount of time for it to read it off the disk, less amount of bandwidth that it consumes to get to the card for memory. The faster your renders will load, and it'll actually process to render. So all stuff to keep in mind. Now I've got some 80 frames here. I think we can hit pause, and let's hit reset. We'll go to VPR again, and we'll take a close look at what we got for a mesh here. Got to make sure that it's going to kick back in with the mesh load. There we go. Right off the bat, I can't see any issues with this. And when we were originally at something like 50 or 45 or 49K, we're now at 11,000 polygons. So let's march it through the timeline, say 50 frames. No perceivable impact on the quality of the render, but what we're looking for are little artifacts in the mesh that would present themselves as faceted quads or triangles. Right now, I'm not really seeing anything. So pretty good to go. All right, let's try it with the other options here. Let's go quads only. Okay, so we'll go back to wireframe mode. Go grab our files. Okay, so how far did we get for this? 76 frames, and we were looking at, well, 82 frames. I was looking at about 500, 600K on average. Okay, so let's delete that, and let's try this 50% with quads only. So we hit reset. Okay, we hit run. Boom. Let's see what we get. These are significantly larger, even with the 50% reduction. Obviously, using the dominant quads, I think it's writing the mesh out a little bit differently. So it may be that even at zero, it's meshing the fluid with a algorithm that actually does a better job of putting it together from a raw data standpoint and possibly a quality look. Now that's pretty slow performance, but we're now working with files that are 100 something K polys on average right at the start. So I'm gonna let this go until about 40 frames, but we can see how much slower this is. 3 megs per frame. So that reduction operation is taking quite a bit of time. And it seems like it's actually writing bigger files. So this option, I don't think is going to work for us. But if you need to work with an engine that favors quads, like Lightwave does, or you perhaps need to write out to a system that doesn't support quads, then you've got the triangles option. So we've got roughly 50 frames in here. Let's hit reset. Let's go back to VPR and take a look at this. Okay. So very dense mesh compared to what we had before. So I don't think we're going to see any of those problems presenting themselves that I described. And we've got a nice quality mesh, but it's still significantly bigger than what we had with just dominant quads. And no mesh reduction. Let's go to triangles. 50%. We'll go through this one more time. Make sure we're working with just wireframe mode so that everything is the same. So we ended up with meshes that started from 1.2 megabytes to roughly 3.5. So let's delete all those. Okay. Let's hit run, overwrite, bring things back in. And again, 50% in triangles. It's not bad. We're very close to what we were getting out of dominant quads at that amount, but we're getting still a performance hit from choosing that options, but we're still working at like 3% on the CPU, 35, maybe spiking up to 50, depending on how much my screen recording software is consuming. And then of course the graphics card GPU power percentage of consumption being what it is. Anything from 10 to 35%. Mesh still seems to be pretty reasonable quality, and our file sizes aren't anywhere near what it was with just quads. So use quads for game engine if you want. So it's pretty much going to be, or pardon me, triangles for the game engine. So it's going to be pretty much universally supported out of the box without any problems. We'll wait until we get to about 45 frames here. Take a look at it in VPR. file sizes are starting to create up there, but again, we basically cut it in half right off the top from what we started with dominant quads at 0. But very interesting stuff in a larger setting. It's going to be very important to do this type of reduction if necessary when you're working with files and go into a real-time environment, AR, VR headset, portable gaming device, cell phones, but also you don't want to be pulling 20 or 30 megabyte or 40 megabyte files 100 times to a bunch of render nodes on a render network if you can avoid doing it and not have any hit in the quality of your mesh. So if you need to reduce the data size, and go about and reduce the data size, because that'll make things just go that much faster. Same thing with Octane. If you're working with a very large mesh that you got to pull it to Octane and you have to do a full scene refresh to get something else to render, then you're going to want to reduce the amount of time that it gets off of your drive or network into your graphics card from system memory and into render. And if you're working on a very, very large shot, or you got a lot of shots to push through, every little ounce of juice that you can squeeze out of data files is going to make a difference. All right, so we've got about 70 frames of this now. Let's hit pause, reset. Let's go back to VPR. Boom, pop it forward. We really shouldn't see any artifacts pop out of this either. Mesh is clean, I don't see any artifacts. Data requirement for this to 28K points, polygons, 56,000. 44K points, or 22K points, 44K polys. No discernible degradation on the mesh. But if mesh reduction is a necessary thing for you, don't use it. Just go with dominant quads, 0, and let it rip. So let's hit reset. Okay, we'll start with fluid mesh. So remember 414K. Let's go back to wireframe. Hit run. And twice the size, but look at how fast it's writing it out. So it's a fine balance. If you are, targeting a game engine, or you need to just do something that's going to load really, really fast for previous purposes, or you've got to work out a shot, but you need the dynamics stuff in there, but you got to bake it because it's going to just work easier for you because you got a lot of characters or something else in the shot that needs to kind of see all this, and you just want to load an OBJ sequence. Probably best off just baking it out really, really quick with the reduction target amount that you want to go for, and play it back as an audio sequence, then go back and rebake to your nice high quality version, and away you go. Again, having fast computer is going to be the key in whether or not you actually have to use these fluid mesh reduction and remesh fluid as functions in this section. And of course, your target platform or desired use. I personally want to see the best results fastest. And this pretty much is the best result fastest because we're not tasking the processor with doing any file reduction whatsoever, which is probably more intense than the calculation of the dynamics on the GPU is. So while they're there, you probably won't really need them or won't have to suffer with them too much. All right, got lots of frames now. And this is not going to have any problems in terms of look. So let's step forward. roughly double the size of the object, 48K polys. And of course, we're not going to have any issues with this in terms of mesh quality or artifacts. It's all going to be nice and pretty looking. All right, so that describes those functions. You probably won't necessarily need them, but they are there. It's good to understand how they work and what they do to the performance of your system and what they have for possible benefits working the other direction, loading into another system or for a target platform. All right, so we're going to continue on with more demonstration scenes and a few other things for Lightwave Flow. So we'll see you in the next video.